Hi. So in the previous code, we have seen that the sample mean of a normally distributed data also follows a normal distribution, right? So now let's take data from some other distribution and see whether distribution of the sample mean again follows the normal distribution. So here everything is same. We are using the same libraries. We are also using 200 samples. In this case, instead of normal distribution, we are taking data from a beta distribution. So these are the parameters to generate a beta distribution. So you know this alpha, beta, and then mu. Then each sample will have, in this case, 50 data points. So this z is for saving our z-scores. So now let's generate our data and then calculate the z-scores. So everything is same, only difference is that we are generating data points using a beta distribution. So this is the parameters, and then we are saving that into a data frame and calculating the mean and standard distribution, then using that mean and standard not standard distribution, this is standard deviation, mean and standard deviation, and then using those values to calculate z-scores and then saving them in z, and then they are saved into a data frame and they are described using the describe function. So here you can see we have 200 z-scores each for each samples. So then we are calculating mean, standard deviation, all the different parameters. So now let's plot and see how the mean of samples are distributed. Okay, we will see the distribution of sample means. So here you can see we are using two subplots, everything is same. We are plotting first a histogram using the z-scores we have calculated, and then we are plotting a probability plot. So let's see. So look here. So here you can see again, in the previous code we used normal distribution, we used data from the normal distribution, but in this case we are using data from a beta distribution, but still the distribution of sample means again follows it approximates to a normal distribution, right? So as we increase the number of samples, it will again become much closer to the normal distribution. So you know this is according to the central limit theorem, right? So this is again proven using the probability plot, where the red line represents a normal distribution, and you can see all the points, they very much lie close to the normal distribution. So these two codes act as a proof for central limit theorem. Thank you.